This video segment begins with an examination of climate forcing factors. Forcing factors such as sunlight and greenhouse gases are responsible for climatic variations that Earth has experienced throughout its history. To predict the future of Earth's climate requires a thorough understanding of forcing factors and how they are likely to change. Forcing factors fall into two categories, external and internal. External forcing factors involve agents outside of Earth and its atmosphere. By contrast, internal forcing factors originate right here on Earth. Variations in sunlight, for example, are external, where variations in greenhouse gas concentrations are internal. This segment focuses on external forcing factors. Its major points are, number one, external forcing factors include galactic variations, solar orbital variations, and sunspots. Number two, galactic variations occur over hundreds of millions of years and thus are uncertain. Number three, sunlight impinging on Earth depends on the cosine law, Kepler's second law, and the inverse square law. 4. Sunlight varies with obliquity, eccentricity, and precession of the solar orbit. Number 5, solar orbital variations may explain glacial and interglacial periods. Last, sunspots have a surprisingly strong influence on climate. Earth is a planet orbiting the Sun, a yellow dwarf star in a spiral galaxy called the Milky Way. Here's a photograph of our galaxy. Who took this picture? Actually, it's a photograph of a galaxy that is similar in size and shape to the Milky Way. The Milky Way rotates around a central axis, completing a rotation every 150 to 350 million years. The quantity and quality of energy reaching Earth from nearby star systems and the interstellar medium undoubtedly varies during this rotation. Several major climatic events such as ice ages, the KT boundary, Great Dying, and Ordovician and Silurian extinction are separated by about 150 to 190 million years and might be coincidental with a period of galactic rotation. Yet the galactic period is so long and so uncertain so as to obscure its influence on Earth's climate. The major driver of Earth's climate is the amount of sunlight that it receives. Three laws, cosine law, Kepler's second law, and inverse square law, relate the amount of sunlight impinging on Earth to its orientation with the Sun. The first is the cosine law. Sunbathers instinctively obey this law in orienting themselves perpendicular to the Sun to maximize the interception of solar rays, or more parallel to the Sun to decrease interception. The sharper the angle between the sunbather and the Sun, the greater the area over which a given amount of solar energy is distributed, and thus a smaller amount of energy per unit area. Mathematically, I equals I sub 0 cosine theta, where I equals the solar energy per unit area. I sub 0 equals the incoming solar energy, and theta is the angle of incidence. In the sunbathing example, the sunbather perpendicular to the Sun is I equals I sub 0 cosine angle of 0 degrees equals I sub 0. The sunbather parallel to the Sun is I equals I sub 0 cosine 90 degrees, which is equal to 0. The cosine law explains many of the differences in climate between the equator and the poles. At the spring and autumn equinoxes, March 20th and September 22nd, the Sun is at midday directly over the equator and focused on a relatively small area, whereas near the poles it is at an oblique angle and spread over a relatively large area. Moreover, at the oblique angle near the poles, solar energy passes a longer distance through the atmosphere and is more likely to be reflected or absorbed before striking the surface. The reflectance of many materials increases at an oblique angle, for example, sunsets reflecting off the water. For all of these reasons, the poles receive less solar energy per unit area than the equator. The cosine law also explains differences among the seasons. Earth rotates daily around an axis that is oriented at an angle of 23.4 degrees away from its plane of the Sun. At the equinoxes, the Sun is directly over the equator, but at the solstices, June 21st or December 21st, the Sun is directly above the Tropic of Cancer, 23.4 degrees north, or the Tropic of Capricorn, 23.4 degrees south. Therefore, on June 21st, the Tropic of Cancer receives full sunlight, and the Tropic of Capricorn receives 68.5% of full sunlight. On December 21st, the reverse applies.